So guys, just like what we solved in the previous video, today also we will be solving another problem on drawing an involute for an object. As stated in the last video, the involute is the curve traced by a tightly wounding or unwinding thread about the object. In the last video, we have drawn an involute for an hexagonal figure which was an edged object. Today we will be solving a question for a curved object like a circle. Okay, so the problem states that we need to draw an involute for a circle of radius 2.5 centimeters or 25 mm. Okay, just like in the previous problem, today also we will be drawing three involutes. One with the thread length less than the circumference of the circle, second for the thread length equal to the circumference of the circle, and last for the involute greater than or the thread length greater than the circumference of the circle. So first of all, what we will be doing is we will be drawing a circle somewhere like 1/3 distance along the length, right, somewhere over here, okay, of radius 2.5, and then we will be dividing that circle into 12 equal parts. Okay, so let's begin. For that, what I will be doing is I will be using my pencil and I will be drawing first two lines. Okay, the first line will be horizontal, and the second line will be perpendicular to that horizontal line. So I will be drawing a line passing through the long short line drawn previously. So guys, can you see over here I have created a center for my circle. I will be drawing a circle of radius 2.5 centimeters. For that I am using a rounder. Okay, in the scale I will be taking a distance equal to 25 mm. For that I have a scale on which I have created a marking for 0. Okay, so this is that 0 mark over here. Okay, then I will be measuring 25 mm in the rounder. So over here it is 25 mm. Can you see? It is 25. Good. So I will be drawing a circle with this. With the center, I have drawn a circle of radius 25 mm. Okay, so I have created 4 basic points. Okay, this is point 1, this is point 3. Okay, I will be taking 2 in between points. Okay, so let's say this is 12, this is 3, this is 6, and this is 9. Okay, for creating all the in between points, I will be using a hexagon method just like what we did in the last problem. Okay, so 2 intercepts, one above, one below. Similarly here also 2 intercepts, one above and one below. From point number 6 and point number 12, we will also be drawing the similar 2 intercepts. I will number all these points. So this was 12, this is 1, this is 2, 3 is already there, 4, 5, 6 is already there, 7, 8, 9 is already there, 10 and 11. Now I will be joining diametrically opposite points and then I will be finishing this problem. Now guys, the next step is to calculate the circumference of this 2.5 centimeter radius circle. The circumference is calculated by the formula 2 into pi into r, which is 2.5, and that gives us 5 pi, or if we convert into decimal we get 15.7 mm. So what I will be doing is I will be drawing a 15.7 centimeter line from this point 12 as a tangent to this circle. Okay, So for that I will be taking my mini drafter, okay, and I will be first drawing a tangent to this circle from point 12. Okay, so this is the line which is tangent to this circle at 12. Now I will be measuring 15.7 centimeter over here, 15.5, 6 and 7. Okay, so this is my point P. Now the next step after locating this point P is to draw tangents from all these points. I have drawn a tangent from 12. Now I will be drawing tangent from all these reference points 1, 2, 3, 4, 5. So for that what we will be doing is we will be identifying, okay, for this point 1 and the point 7 the perpendicular line is 10, 4. Okay, so I will be keeping my roller scale parallel to 10, 4. Okay, I will pull it towards 1. Okay, and then I will be drawing a line. Okay, for this line 8, 2, the perpendicular line will be 11, 5. I will keep my roller scale parallel to 11, 5 and I will draw a line. Okay, be very careful while drawing the parallel lines with roller scale, that even the smallest disturbance will create an impact on your drawing. Okay, so the two tangents we have drawn. Now this 12, 6 line is perpendicular to this 3 point. So I will be keeping my roller scale parallel to 6, 12, taking it to 3, locating 3 on the line and then I will draw a line. Okay, so I will complete this entire practice. Now I will draw tangents to 4, 5, 6 up to 11. Okay, and then the next step we will start from there. So now you can see that I have drawn the tangents from all the 12 reference points, okay, in the respective directions. Now I have to divide this 12p line into 12 equal parts. So for that I will be drawing an angled line from point 12. Okay, angle can be anything. Okay, now I will be measuring the 12 centimeter distance on this line. Okay, so let's start say from 10 up to 22. So I have coincided 12 point with 10 centimeter mark on my scale. Okay, I have kept my scale parallel to this line. Okay, now I will be drawing all the reference points. So this is 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. I will number them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Next step is to connect this 12p line. Okay, so for connecting 12p I am using a regular ruler, but then afterwards I will be using a roller scale and drawing line parallel to this 12p line from 11, 10, 9 and get 11 dash, 10 dash, 9 dash and points respectively. Now to draw the involute curve, what I have to do is, as I have plotted all these points 1 dash, 2 dash, 3 dash, 4 dash, 5 dash up to 11 dash. Now in order to take the next point P1 on this tangent from point 1, I will be taking my rounder at 1 dash point, taking distance equal to 1 dash P, right, and then I will choose this point 1 on the circle, right, and make one arc on this tangent line. This point is my point P1. Okay, now in order to draw the second point or identify the second point, I will go to point 2 dash, take a distance in my rounder equal to 2 dash p, okay, like this. I'll go to point 2 and create a arc on my tangent from point 2. Point 3, 3 dash p, yes. So I have a point reference to p dash 3. From point 3, I will create another arc. Okay, now I will keep on continuing the same process for 4, 4 dash p, for 5, 5 dash p, for 6, 6 dash p, and so on till I get my point up to 11, that is 11 dash p. Okay, so let's complete this. So guys, I have created all the intersections on all the respective tangents. Okay, so first is P, then P1, then P2, P3, P4, P5, P6, P7, P8, P9, P10, P11, and this starting point 12 point is my P12. Now I have to draw a freehand curve connecting all these points. Okay, or I can use French curve also. Okay, at this moment I am not using a French curve. Okay, since I want you guys to teach about freehand drawings. Okay, so this is the involute, half the involute I would say, remaining half I am drawing. Always there is a possibility that you might make a mistake, so use a good eraser. Connect P2, P1 also. Again, a small mistake. If you are using a French curve, you have to choose 2 points at once and then start connecting them. So there is bit of flattening over here. Okay, so I would like to correct that because I don't want you to have an impression that yes, even the flat curves are acceptable. So I am using a good quality eraser over here. Okay, but still draw lines as faint as possible. Okay, so this is our curve. Okay, so this is the first involute. Involute for P. Okay, now as I have told, there are 3 cases. This is the second one. I will be drawing the third case where the point is beyond this circumference. Okay, because previously in the last video I have drawn an involute for a point which lies within this circumference of that particular object. Okay, that was a hexagon, so it was a perimeter. Here it is circumference. So the circumference of this circle was 15.7. I will be taking a point which is like 17 mm. Okay, so let's coincide one with this point 12 and take a point which is at 17 centimeter. Okay, so I will name this point as Q. Okay, I will again follow the same procedure. Okay, but now instead of finishing the curve at P12 or point 12, this curve will extend beyond this point. Okay, and it will be close to somewhere between 1 and 2. So let's draw the intersections. Same procedure I will follow for drawing or taking a point Q1 on this tangent of 1. I will take a distance equal to 1 dash Q, 2 dash Q for 2, 3 dash Q for 3, and so on. At P point, what I will get an intersection on this horizontal line again somewhere over here, and then I will keep on increasing this distance to get the further points. Now guys, I have created all the points Q, Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8, Q9, Q10, Q11, Q12 which is on the horizontal line again, and then this Q1 dash which is in between 1 and 2 on the circle. Okay, so I have to draw this line like this. Okay, and can you see all these points are parallel to the previous ones, and if I connect these points, I will get an involute which is parallel to the previous one. Right, and this last one. Right, if I draw another point, say somewhere over here, say R, okay, since it is in between 10 dash and 11 dash, it will end somewhere close to, or somewhere in between this over here, R dash. Okay, so for that you need to draw this problem on your own as an homework and finish the problem with this P, Q and R involute. So this is our second involute. Involute for Q. Involute for R is for the homework.